So V0 here, once again, is our initial amount, which would actually be 27,000. So this gives us 27,000 e to the kt. So we're required to find k. That's the first thing they ask us to find. Now, from the information given here, you'll realize that there's actually three unknowns, right? We don't know k, we don't know t, and we do not know the value v. So it's going to be very difficult to find k if we have three unknowns. However, they did give us this information at the very top, which is where this is going to come into play. They tell us that the value is 99,095,000. And we have E and K, and we can also find T. So in 2004, what would T be equal to? And be careful, Marta, in 1950, T is equal to 0. That's the initial time, initial value. So in 2004, what would our T be equal to? I agree with you, right? So all of it is 2004 and minus 1950 to get the time, which is 54. So this becomes 54. So now we can actually solve for k, which is what they're initially asking us to find. So we can divide both sides by 27,000. And that will give us e to the 54k. You guys get for that when you do the division. 3670.2. Now when you're doing your calculations here, please try and do as many decimal places as possible. I'm just going to go with the 1 for now for simplicity. But you should do a minimum of 4 decimal places. What do we do now? How do we solve this? This goes back to some of our earlier sections. We're going to take the ln of both sides. So this becomes the ln of 3670.2 is equal to 54k. Because we know the ln will cancel out the e. It's one of the reasons why we do that. So here we go. So k is actually equal to the ln of 3670.2 over 54. So what do we get to k? What's our k value? Anyone? 0.152. All right. So now we can go back and write our equation that we had here. We can now fill in for the value of K. So we know V is equal to 27,000 e to the 0.152 times t. So that's the second part of the question, which was to determine the exponential growth function. So part A in itself had two parts. Let's look at part B of this question. So here it's asking us to predict the value in 2023. So how do we do that? How do we do this? Come on. How do we predict the value of the painting in 2023?
Find the t value.
So find the t value. What is the here?
73.
73. Thanks, Jenny. And we got t to be equal to 73 because we took 2023 and we subtract 1950, right? Which is when t was equal to 0. Damien, you said t is equal to 19. You sure? I think you were calculating it from 2005, I think. Probably why. Or 4. We're calculating, so it is 73. So now our value after 73 years will be 27,000. E to the 0.152 times 73. All right. What our answer for this? um, 779, all right. Oh, since you guys got that, we'll just go with an answer. Can you hear me now? All right. So now we're finding the rate of the painting in value in 2023. If you remember the last class, we said that the rate of change for these exponential function is equal to k times the original function. And we know our k here was 0.152. And we know v of 73 is what we just calculated, which is 1,779,489,113.
Sorry, can you go over where you're pulling these values again?
1 second. I'm just copying the problem. All right. Which one are you talking about?
The 0.152, like both values, can you go back up?
All right. Yeah. So k, the 0.152 was the k here we had calculated earlier. So remember we calculated k, which was 0.152.
Okay, thank you.
And the next one, which was v of 73, is what we just calculated here, part B. Because we're trying to calculate a value in 73 years. So we already calculated both parts of that. So it's just a matter of just plugging in the numbers.
Okay, thank you.
You're welcome. And we got 270,482,345.2. Assuming that all these numbers are right. Well, the process is right. So what is this saying? 73 years after the painting was done, it's changing at a rate of $270 million per year. So every year, the value of this painting goes up $270 million. That is ridiculous. All right, let's do part D. I think part D is our final part for this question. How long after 1950 will the value of the painting be 5 billion? So we know our V of T is equal to 27,000 e to the 0.152 times T. So what are we trying to find in this problem? At least in this section.
T.
We're trying to find T. We're trying to find how long, the time, right? So what does this 5 billion represent then? CFT, very good. That's the current value, right? So we're going to put 5 billion here. It's 5 million. That'll be 5 billion. That's always a million, right? Is equal to 27,000 e to the 0.152 t. Once again, we're just going to divide this by 27,000. Which gives us e to the 1.152 t. What do we get for that division? One 5185. 0.18. And to solve this, we're going to take the ln of both sides. So this becomes 0.152 t. And what do we get on the left side when we took the ln of 185,185.18? Anyone? Just do this in your calculator. What's the answer for this? 12.129. Thanks, Bruce. And then we're going to divide by 0.152, divide by 0.152. Come on, this is the easy part. Sticking the stuff in our calculator. It's just find a natural log and know we're dividing. So what's 12.129 divided by 0.152? 79.797 years. So it takes approximately 8 years for this painting to reach $5 billion. That originally cost $27,000.